from like my last unit, which I didn't understand. But okay, so basically our last unit had to do with like graphing and writing equations, like quadratic equations and like absolute value and like square root and stuff.
Okay.
So
Can you, the way I usually do my tutoring is all problem based.
okay.
It's not so much concept based. I mean,
Okay.
if I see that you're having problems with solving a certain problem and I can see a concept that I can explain to you, then I'll do that. But it all begins with you giving me problems that you're not sure how to solve.
Sounds good.
Don't give me the easy ones. Give me the ones that you're not sure how to solve.
Okay, so here is a problem, and it's y equals negative and then root 16, and then this is all under the radical. So root 16 minus, and then in parentheses, x plus 1, and then end the parentheses, and then squared, and then outside of the radical plus 3.
Okay, and what is your job here?
To graph it.
Okay. Well, I will say this. The IB program certainly gives you challenging problems.
Yeah.
So, let's talk about Vertex Format. What's Vertex Format?
Is that like the parent, like?
Well, whenever you're dealing with quadratics, what you're really dealing with is parabolas, every one of them, and there are a number of formats. Okay, and perhaps maybe that's where we should start here. Hold on, let me just, on the right side here, I'm going to call this Vertex Format, and there's 3 of them, and this is looking familiar.
Oh wait, hold on.
Hold on a second. I'm going to have to start this a little bit further right. Incidentally, you will get a copy of this, a recording. So if you're taking notes or not something, it's actually probably is going to work better for you if you don't. You'll always be able to review it. Okay. And taking notes, I understand that it's some people's way of how you learn stuff. And I don't have any problem with that. But just so you know, you're going to get a recording of it. Okay. So that is Vertex Format, where the vertex is H, comma, K. Okay. You familiar with that? I'm going to ask because IB teaches a different way. They really do. And so I can't assume much of anything. Standard format would be this. Y equals AX squared plus BX plus C.
Okay.
And you even have X-Intercept Format. Which is y equals a, same a in all 3 cases, incidentally, x minus p times x minus q, where p and q are the x-intercepts of this parabola.
Could they also be like, could that also be H and K, or with the P and Q?
Vertex format. Notice the difference. In other words, here, let me draw a standard looking parabola over here. Something like that. And I will call that 3 minus 2. Okay?
Okay.
So if I have a quadratic that is in vertex format, it's pretty cool because you know exactly where the most important point is. And that's at H and K. Okay? In other words, the equation of this kind of parabola might be something like y equals 2 times x minus 3 squared minus 2.
And what is the k again? The plus k?
K is the y coordinate of the vertex.
Oh, okay.
H is the x coordinate.
So what is the A? Like, where did you get the A from?
A is remember back to algebra where you had vertical stretch factors? That's what A is. In other words, that parabola may not look exactly like I've drawn it. It may look something more like this. But the fact is that the vertex is in the same spot.
Okay.
So the beauty of the vertex format is that it tells you immediately where the vertex is.
So how would you find that that it's being stretched by a factor of 2?
Well, that's what A is. In other words, if A were 2, like it is here, that's going to make that parabola a little thinner.
No, I know, but like, how would you find from looking at that?
It kind of depends on the way they give you the equation. Okay? Now, usually it's very clearly in one of these 3 formats.
Right.
Okay? Well, let's look at what they gave us. Let me erase some of this stuff so that I have a little room to write. Which format does this look like it's in?
Probably Vertex Format.
That's what it looks like to me. It's a strange vertex format, but maybe not as strange as it looks. It looks to me like, in other words, it's not directly in that format. It's got a radical sign there. A would appear to be minus 1, but I'm not sure we can say that yet. K would appear to be plus 3.
Okay. Right.
But what do we do with that radical sign? Well, what should we do with it? What should our first step be?
Would you square the radical?
I think so, because I don't know what else to do with this. In other words, it's in such a strange format that it's not a standard quadratic. However, maybe it'll turn into one if we do what you suggested, which is to square that. You know what that is squared? Quickly?
I mean, it would just be negative 16 minus x plus 1.
Now, hold on. The negative sign was in front of the radical or not?
Oh, yeah, it is in front of the radical.
So the first step is to square that. What is that squared?
What's underneath the radical, you mean?
No, just this part here.
Oh, just that part?
The very next thing that we can do is that. That's it. I don't know anything else we could do. But maybe if we go ahead and square that and subtract it from 16, we'll find something that is a perfect square. In which case we will be able to turn this thing into something that looks more like a standard vertex format.
So you would do FOIL, right?
Yeah.
So like,
it's, you know what? There's certain things you kind of want to remember. That's one of them. And
So
I don't mean x plus 1 squared, I mean anything squared. In other words, if I have a plus b squared, doesn't matter what a and b are, it's a squared plus 2ab plus b squared.
okay.
So when I'm squaring x plus 1 squared, first of all, don't make the most common mistake that algebra students make, which is calling the answer x squared plus 1.
Right.
It's not that. Okay?
Right. I know.
So make sure you understand this down here. And likewise, I'm sure they've stressed this in your school, to memorize these as opposed to having to always FOIL it. When you have to FOIL it, it takes you maybe 30 seconds. If you memorize it, it takes you about 5 seconds.
Right. Yeah, that makes sense.
Okay.
So I got x plus 1 squared to be x squared plus 2x plus 1.
Okay, now let's combine everything and see what we got. I'm not sure yet whether we're going to find a perfect square or not, but okay, let's see. So that's minus x squared minus 2x minus 1 plus 16, which is plus 15, plus 3 outside. Wow. You're not making this easy. What I was hoping is that we would end up with something that was a perfect square, like x plus 3 squared. And then, when you took the square root of it, you would have x plus 3.
I mean, this is supposed to be graphed, so do you have to solve it all the way?
We don't. Okay.
It's supposed to be graphed as a circle or an ellipse. Did I totally take you?
This is not a quadratic, then.
No, sorry.
That helps a lot. Okay. Yeah, I was kind of shooting from the hip trying to solve this as a quadratic, and that's why I covered all 3 formats of a quadratic.
That's okay.
Let's go back. I thought you said quadratic when you first started talking about it. And so I was assuming this was a very strange form of a quadratic. It's not quadratic. Now that I look at it, I can see what it is. If we square both sides, we will get something that looks like a circle or an ellipse. Because, okay, so you've had conic sections.
I said what?
Conic. They're called conic sections. There's
okay.
four types of conic sections. There are parabolas, which are your quadratics. There are circles, there are ellipses, and there are hyperbolas. In fact, let me draw them. Parabolas, okay. That's something that looks like that or like that. It can also be horizontal. So it can look like that or like that. Circles, obviously, look like that. Ellipses look like either this or this. And in fact, ellipses can be tilted like that also. They don't have to necessarily be horizontal or vertical. And finally, you have hyperbolas, which usually look like this or that, or this or that. And those can also be tilted so that they look like that or like that. Okay? Those are your conic sections. And parabolas can also be tilted where they look like that. Okay? So, each of these has a standard equation For example, a circle might look like this. X squared plus y squared equals 16. That
Right.
is a circle at the origin with radius 4.
Mm-hmm.
Okay? If it's x minus 2 squared plus y minus 3 squared equals 16, then this is a circle not whose center is at the origin, but whose center is at 2, 3.
Okay.
Still has a radius of 4.
Mm-hmm.
Okay?
Right.
Yeah, this is always r squared over here.
Right.
Okay?
Okay. Right.
So your radius is always going to be the square root of that number on the right.
Mm-hmm.
Ellipses have little different format. Ellipses are very similar to circles. The only difference is that they kind of have two radiuses. In other words, if I look over here at my ellipse, I could call that radius A.
Right.
And that radius B.
Okay.
The equation of the ellipse looks something like this. Instead of
Right.
equaling r squared, it's equal to 1.
Right.
Okay?
Mm-hmm.
And depending on whether it's horizontal or vertical, A is bigger than B, or A squared is under the Y term, whatever.
Mm-hmm.
And when you start, are you actually dealing with diagonal ellipses like that?
No, not
Wouldn't think so. Most high school students don't deal with those. That's college. That's college conic sections.
Yeah.
Well, good. So if we go back and we look at our equation again, now that I kind of know that it's not a parabola, and I can see why it isn't, if I square both sides, I get y squared equals, well, how do I square that?
Wouldn't you square what's underneath the radical so that the radical goes away, and then square the 3 so it's equal to 9?
Yeah, but there's also a middle term. Remember, when you are squaring a plus b quantity squared, you don't get a squared plus b squared. You get a squared plus 2ab plus b squared.
Oh, okay.
Okay? So in this case, if I'm squaring both sides, that's a, that's b.
Okay.
So the very first term I'm going to have is a squared. Well, that negative sign goes away because I'm squaring it. The radical sign goes away, and I'm left with this, whatever was inside that radical.
Okay.
Okay, that's my a squared. Now, 2 times a times b, well, that's going to be 6 times this. And it's minus because of that leading minus sign.
Okay.
Still not sure how this is going to help, but at least I'm going, I feel like, in the right direction. And finally, b squared is 9.
Mm.
So I have that.
Okay.
Now, this looks like it has to be an ellipse.
Yeah.
The reason is that when you look at a standard polynomial, if it's got an x squared and a y squared, same coefficients, and they're being added, it's a circle. If it's got an x squared and a y squared and they have a different denominator or coefficient, actually, it's an ellipse.
Mm-hmm.
So this, I can tell it's going to have an x squared in it.
Mm-hmm.
Both from this term here and that term there. And it's got a y squared already.
Mm-hmm.
So I think I'm looking at an ellipse. Now the question is what to do with it.
Well, it wants you to just graph it. So I guess like my main questions are how you would find the center point, and then how you would find radius A and radius B.
All right.
And then how you would graph it.
If we expand this just a little bit, we get this. 16 minus the quantity x squared plus 2x plus 1, which becomes 15 minus x squared minus 2x. And then we have under the radical sign, notice that same thing. 16 minus that same thing. So it's got to be that same thing right there.
Mm-hmm. Oh, okay.
Okay, in other words, I don't have to spend time doing that math. And then I have that.
Mm-hmm.
This actually is looking more and more like a parabola the more I look at it.
I mean, it's this one isn't.
Well, now hold on. We got it equal to y squared. I'm sorry. I take that back. Now it is looking like a circle because I can't believe you have a problem this hard, but okay.
I mean, isn't there a way?
If the y squared is all by itself and it doesn't have a y term, then that means that the origin of the circle is on the y-axis.
Okay.
If it's got an x squared and an x term, then the origin of that circle is not on the y-axis. It's, in other words, it's going to, instead of being like this, it'll be scooted over like that. So you can see that the origin is still 0 on the y-axis, but it would have a translated position on the x-axis. And that translation has everything to do with that and completing the square. And it looks to me like in order to do any of that, we're going to have to use some level of substitution here.
Mm-hmm.
I don't know if you're even familiar with that term, are you? Substitution?
I mean, like substituting in like for x, substituting in like a 1.
They've given us an extremely complicated thing here, but it's really a quadratic. This thing over here is a quadratic in disguise. And by that, I mean if I let that term equal u squared, then this is going to be u, correct?
Mm-hmm.
So now I have this. And this term can actually be written as u minus 3 quantity squared. And now we have our not a circle. The heck is it?
I mean, do you really need to, like, solve through the, like, isn't there a way when it's, like, the original equation, the negative root 16 minus x plus 1 squared plus 3 outside the radical, isn't there a way through that to, like, evaluate, like, the x plus 1, the 1 is, like, is the negative h value? So, like,
but the problem is that you cannot take the square root of something that's not a perfect square. I cannot take the square root of that. Okay? I could take the square root of that, which is merely x plus 1.
Mm-hmm.
So when we simplify what's inside the radical, we get basically x squared with a 15 on the end of it. And there is no square root of that. So there's no way we can apply the radical sign to that. Now, are you sure this is the way it reads in your book? In other words, do I have the 3 outside the radical sign and everything else is inside and that first negative sign is outside?
Yes, it's just supposed to, yeah, that, and then it's supposed to be as a circle.
I don't even know how to put that into Vertex Format. Even though it looks kind of like it's in Vertex Format, I don't know how to simplify that right there. Even though I'm looking at difference of squares, so that's 4 minus that times 4 plus that. But I don't know how to take the square root of that either.
Well, would the 16, like, okay, so the root, if you looked at, like, the parent function of a, I guess it would be a circle, I think. Isn't it like root r?
In other words, if I get down to using substitution, which seems reasonable because here, in other words, when I call this a disguised quadratic, what I mean is that that term is the square of that term, is it not?
Right.
And I also have a number. So that fits the definition of a quadratic, x squared minus x plus some number. Okay? So the thing is, for me to make sense of all this, I have to use this substitution method where I let u be this middle term, and then that makes this u squared. And now I actually have something that looks like, let's see, that actually looks like a hyperbola. In other words, no, hold on a second. I gotta have 1 on the other side, not 0. Do you happen to know what this is? What the shape is? Is it a parabola, circle, ellipse, or a hyperbola?
It says it's either a circle or an ellipse, but looking at my equations, it should be a circle. It should be a circle in the form.
Here, let's look at this just a little different. Let me look at this. Let me take that last step out right there. Look at my last row. Let me erase some of this stuff. Now I see what I did wrong. In other words, if it's a circle or an ellipse, then I want this equation to look a little different. Okay. In other words, if I take this equation and start working with it, I get y squared minus u squared plus 6u, and I can leave the 9 over on the other side. Okay, I haven't changed anything. Now I go to complete the square in the middle. Okay, now I have to subtract 9 from the other side, and I get a degenerative conic section that's a hyperbola. It's degenerative because this always needs to be 1, and I don't really have a way to make that 1.
Well, if it's not an ellipse, then it doesn't have to be, like, because, so the parent function of a circle, one of them is x minus h squared plus y minus k squared equals r squared.
Correct.
But then the other way you can do it.
That's the big one. In other words, that is the equation of a circle anywhere. It doesn't have to be at the origin.
Right.
Okay.
And then,
yeah.
But then,
go ahead.
The other equation that you could use would be y equals, and then wouldn't it be plus or minus, and then all under the radical r squared?
Yep.
Minus, and then in parentheses, x minus h, and then end parentheses squared.
Correct, like that.
Outside the radical, plus k. So if you look at the original equation, then wouldn't the
Hold on 1 second. The k is still over there.
Yeah,
so
it's
still, okay, now I'm going to add outside the radical plus k. Okay, go ahead.
So then if you look at the original, the equation of the problem.
Now we're talking. Yeah, I'm not used to looking at these things like that. All right. So the original equation again was y equals what?
It is, sorry, 1 second. It is negative and then root 16 minus, and then in parentheses, x plus 1 squared, and then outside the radical plus 3.
All right.
So then your
there we go. Now we can identify everything, huh?
So your radius would be 4.
Yeah.
Would your center point start at -1, 3?
That's all you need to know, huh? So it's -1, 3, and a radius of 4. There you go. Interesting. Yeah.
Okay.
I have never been presented with a problem in that format before. They actually solve it for y, and then they give you an equation that looks very much like what you would get if you solve this for y. So, yeah, it's definitely a circle. It fits the perfect format.
Okay.
I just was not familiar with that format, which is just an algebraic solution. Now, what does it mean that it's negative only? Do you know? I do. I didn't draw it right.
I actually don't know what that means.
It means it's the lower half of that circle only.
Oh, okay.
Okay. In other words, let's talk about that for just a second.
Okay.
The circle is not a function. Notice that when you do solve it, let's talk about a circle. We'll make it a simple one at the origin. Like that. Okay. The negative is this part down here. The positive is this part up here. Each one of them individually are a function. Together, they're not. Notice it does not pass the vertical line test. And it is a composite. It's called a relation, not a function, because it's not a function. It doesn't pass the vertical line test. But the one they gave you had just the negative sign.
Right.
Which means that they're just giving you the lower half of that circle.
Okay.
So what they gave you actually, and I know that 3 is outside the radical sign, but what they gave you was a function. It's a semicircle. And that's all. That's a very interesting problem. I gotta hand it to IB. I've been tutoring for 10 years, all levels of math, and when I find an IB student or somebody that's pre-IB, they present these problems in just different ways.
Yeah, definitely.
Yeah. So, okay, well, listen, I've gone beyond the half-hour point here.
Okay.
But I appreciate you explaining this to me so I could figure it out. But anyway, Naomi, that's how my sessions work. And either you or your mom, I think, know how to go to my website and schedule further sessions if you want. I am recording this, and I will send you a copy of this file by tomorrow morning.
Thank you.
And you guys can decide what you want to do going forward here.
All right.
Okay.
Thank you
Good night.
so much.
Have a good one. You're welcome. Bye-bye.